Hi students, in this video you are going to learn about the basic physics for beginners. I am going to tell you the essential terminologies. Many of the students, whenever they joined in intermediate first year, and some students they will complete first year and they join in second year. But whenever when they joined in first year or second year, some students they feel difficulties in still in understanding the concepts of physics. The reason behind is because they have a lack of the basic terms which they have skipped, which they have not learned, which are essential for them. In this video I am going to explain you that what are the basic physics. So see here, these terminologies they will make your the concepts more strong. Okay, fine. So let us discuss about essential terminologies which are very important for you in while solving the numericals or learning some concepts. See here, we know that some fundamentals in physics, some basics in physics we learn about. In English, we have letters like A, B, C, D, alphabets. Similarly, in physics, we have symbols like Greek letter, like alpha, beta, and many Greek letter symbols are there that you must have to know. So, because the importance of those letters are very, very much in physics. Now, we know that the multipliers like kilo, mega, giga, milli, micro, etc. So all these are the multipliers which are the basics terms you need to learn in physics. Let us see. Coming to the symbols. Here if you observe, here I have just few basic symbols I am explaining here. I am going to tell you. See here. Here the blue color, whatever you are not able to observe here, the blue color, in blue color, so they have no need. So like we have capitals and small letters in English alphabet, similarly we have the alphabets in Greek letters also. See, many times we use the term alpha in physics. So alpha, this is a symbol of for alpha. Next, and the capitals here, all these are capital and these are small letters. And beta, this is a symbol for beta. Next, gamma, so this is a symbol for gamma. And delta, so in delta, the capital letter of the delta is important. So I have placed over here. So here you can see the capitals of delta, and here the small letter of in denoting the delta. And next, epsilon, so it looks like small e. So this is a small letter which we denote epsilon. And next, eta, see here, this is a symbol of eta. Many of them they pronounce this as new, but that is wrong. Actually new, here I have given new, it looks like v. So this is not new, this is a eta. Next, theta, so this symbol also we have we are using many times. That is also very important. Next, iota, it looks like small I. And next, kappa, so it's a small k. Lambda, so lambda, this is a symbol for lambda, which we used to measure wavelength, okay, in sound chapter, in waves. So we use this symbol lambda. Next, the symbol of for mu, or these are small letters. Next, nu, it looks like v. Next, pi, so we know that in mathematics or even in physics also we use pi symbol. So this is a symbol of pi. Small pi is denoted with a small letter. Next, rho, so rho, sometimes we in electric current we use for resistivity also, rho. So this is a symbol for rho. And next, sigma, in mathematics we call it as summation also. So this is a capital letter of sigma, and this is the small letter of sigma here. And next, tau, this is a symbol for tau. Next, phi, so phi can be represented in this manner. Next, chi, so it looks like x is chi. Next, psi, so this is a symbol for psi, it looks like a, so this is a symbol. Next, omega, so in resistance, in electric current we use ohm, this symbol as ohm also. Here, but we call it as omega, and this is a small letter of omega. Okay, so these are about the Greek alphabets. Now let us discuss about the next one, multipliers. See, in physics, actually Up to here I have started with 10 to the power of 1 to 10 to the power of 18. So these factors or multipliers are enough for your first year or even in second year intermediate. So I have here you observe that. So these are the extra terms. So that is, it is better if you learn more than that. Now coming to the factors, if you observe, so 10 to the power of 18 hexa symbol. So all here you observe the maximum symbols are in capital letters. So giga, 10 to the power of 9. Next kilo, we know that kilo 10 to the power of 3. Next hecto 10 square. Deca 10 to the power of 1. So here it is denoted with the dA or small d. Here a small dA, and deci we use small d. And here you observe that all these are in terms of 3. If you observe all positive factors here, and here you observe zeta byte. You may have seen the picture, robo. So here the you observe the robo says that my capacity, my storage is 10 to the power of 21 zettabyte. That is my speed. So here you can observe that 20 to the power of 21 zeta and 10 to the power of 24 iota. So all these are denoted with capital letters, so symbols. And here you observe sub multiples, zepto, small z, 10 to the power of minus. So all the minus powers are denoted with small letters, small symbols. So centi 10 to the power of minus 2, milli, micro 10 to the power of minus 6, and octa. Except all these are the small terms. So you need to remember all these, because why? Suppose if you are calculating, if you are doing any numericals, in conversions they are very useful. I will show you example here. You observe conversions. 1 kilowatt, kilo nothing but here if you observe, the kilo is given 10 to the power of 3 watts. So while we are converting, that is a very important thing. Next, 1 megawatt, mega means 10 to the power of 6. So if you observe here mega, so while these are useful in converting conversions. So next, 1 picosecond, so 10 to the power of minus 12 seconds. Next, zeta, already I have explained all these. So these terms, these are very important that we use in numericals while doing conversions. Now coming to the some important constants. Already you have learned, see in 9th and 10th, you learned some constant values. But whenever you go to the inter level, so we learn many things or many constants that are very useful for us in solving the problems. So here if you observe the first one, speed of light in vacuum, 3 into 10 to the power of 8 meter per second. You have learned already. Now coming to the Avogadro's number. So N and A, it is noted with Na. So 6.022 into 10 to the power of 23 per mole. And next, charge of electron or proton. So we know that electron denoted with minus symbol and proton is denoted with a plus positive symbol. So proton is plus 1.6 into 10 to the power of minus 19 coulombs, and electron minus 1.6 into 10 to the power of minus 19 coulombs. Next, mass of electron. So 9.1 into 10 to the power of minus 31 kg. Next, mass of proton or neutron. So here you observe that 1.67 into 10 to the power of minus 27 kilograms. So here you observe that the mass of neutron is little bit, it is greater than mass of proton. So these are the important things you need to remember. Next, acceleration due to gravity. See, actually this acceleration due to gravity is different at poles. Okay, and next at here, but we learned about the Earth's surface. We'll consider it. So Earth's surface, the acceleration due to gravity is 9.8 meter per second square. Now, and coming to this one, universal gravitational constant. So even this will be, it is constant even when you learn about the distance, whenever you are learning about the distance between planets, okay, or any two bodies. So see here the universal gravitational constant G is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So you know that this was given by Henry Cavendish. Now coming to universal gas constant 8.314 joule per mole per Kelvin. So all this you learn in chemistry. Next, Planck's constant, even somewhat you learn in physics also. So here the constant which are given, which you learn in both physics and chemistry. Next, Planck's constant, this is also very important, 6.626 into 10 to the power of minus 34 joule second. So some we can write it as 6.63 also, sometimes 6.63 into 10 to the power of minus 34 joule second. Next, Rydberg's constant. So here you observe it is denoted with capital R, here also capital R, don't get confused. But this is the terminology which we use is different. 1.097 into 10 to the power of 7 per meters. Okay, next, this permittivity of free space. Here you will observe the epsilon naught. Actually, this you learn in we learn in electric field. Okay, so that all I will explain in detail. Okay, now coming to this constant, you remember this value 8.85 into 10 to the power of minus 12 is coulomb square per Newton per meter square. So this is a value of epsilon naught. Next, permeability of free space mu naught. Okay, this we learn in magnetic field. Okay, next the value here you observe 4 pi into 10 to the power of minus 7. The T nothing but Tesla meter per ampere. So many constants are there. So these are the important constants you must remember. So that we use in intermediate. Okay, next, and here you observe that. So permittivity of free space. So 1 by 4 pi epsilon naught. Suppose if you the epsilon naught, if this value if you substitute here and if you calculate, you will get finally 9 into 10 to the power of, actually it is 10 to the power of 9. Okay, so this is what here it was given wrong. Okay, fine. So all these are the basic important terminologies you must learn and you must remember, so that this will be make your fundamentals strong. Okay, hope you have understood all the some basics and many terminologies you need to remember. So in the next video I will make that also, and so that will be very helpful for you in intermediate or in higher education, higher like in the first year or second year. Thank you very much.